Imagine a world where your daily commute is not only effortless, but also environmentally friendly. A world where traffic jams, parking woes, and accidents are a thing of the past. This is not a fantasy, but a rapidly approaching reality, thanks to the convergence of artificial intelligence, AI, and electric vehicles, EVs. In this video, we'll embark on a journey to explore how autonomous vehicles and EVs are set to revolutionize transportation, reshape our cities, and transform our daily lives. Buckle up, because the future is closer than you think.
Part 1. The Visionaries, Elon Musk and Seba. At the forefront of this revolution are two visionary figures, Elon Musk and Seba. Elon Musk, the charismatic CEO of Tesla, has been a driving force behind the mass adoption of EVs and the development of autonomous vehicle technology. His relentless pursuit of innovation has propelled Tesla to become the world's most valuable automaker, with a market capitalization surpassing that of traditional giants like Toyota and Volkswagen.
But Musk's vision extends far beyond just selling cars. He envisions a future where autonomous EVs are not only the norm, but also a means to create a more sustainable and efficient world. With Tesla's autopilot system constantly evolving, and the company's plans for a RoboTaxi network, Musk is determined to make autonomous, electric transportation accessible to everyone.
Alongside Musk, Seba, a renowned futurist and clean energy expert, has been accurately predicting the disruptive potential of EVs and autonomous vehicles for over a decade. In his groundbreaking book, Clean Disruption, Seba forecasted that the convergence of EVs, autonomous technology, and ride-sharing services would completely transform the automotive industry by 2030.
Seba's predictions, once considered outlandish, are now coming to fruition at an astonishing pace. His insights into the exponential growth of battery technology, declining costs of EVs, and the rapid advancement of AI have made him a leading voice in the transportation revolution.
The rise of electric vehicles. The foundation of this transformation lies in the rise of electric vehicles. Once a niche market, EVs have now entered the mainstream thanks to the efforts of companies like Tesla, Nissan, and GM. The increasing affordability, longer ranges, and expanding charging infrastructure have made EVs a viable option for a growing number of consumers.
But the benefits of EVs extend far beyond personal convenience. The shift towards electric mobility is crucial in the fight against climate change. Transportation is one of the largest contributors to greenhouse gas emissions, and the widespread adoption of EVs can significantly reduce our carbon footprint. By replacing gasoline-powered vehicles with clean electric alternatives, we can create a more sustainable future for generations to come.
Moreover, EVs are not just environmentally friendly, they are also cheaper to operate and maintain. With fewer moving parts and no need for regular oil changes, EVs have lower maintenance costs compared to their gasoline counterparts. As battery technology continues to improve and economies of scale drive down prices, the total cost of ownership for EVs is becoming increasingly competitive.
Part 2. The Autonomous Revolution. While the rise of EVs is impressive, the true game changer lies in the development of autonomous vehicle technology. Autonomous vehicles, powered by advanced AI algorithms, have the potential to revolutionize transportation on a scale not seen since the invention of the automobile itself.
Imagine a world where you can summon a driverless car with the tap of a button on your smartphone. A world where you can sit back, relax, and let the car navigate through traffic while you work, read, or simply enjoy the ride. This is the promise of autonomous vehicles, and it's no longer the stuff of science fiction.
Companies like Tesla, Waymo, and Cruise are already testing their autonomous vehicle technology on public roads, racking up millions of miles and gathering valuable data to refine their systems. These self-driving cars are equipped with a suite of sensors, including cameras, radar, and LiDAR, which allow them to perceive and navigate their surroundings with incredible precision.
The benefits of autonomous vehicles are vast. First and foremost, they have the potential to dramatically reduce accidents and save countless lives. Human error is responsible for over 90% of traffic accidents, And autonomous vehicles can eliminate these risks by removing the human factor from the equation. With their 360-degree perception and lightning-fast reaction times, autonomous vehicles can respond to hazards much more effectively than human drivers.
Moreover, autonomous vehicles can help alleviate traffic congestion and optimize road usage. By communicating with each other and with traffic management systems, autonomous vehicles can coordinate their movements, reduce bottlenecks, and streamline traffic flow. This not only saves time for commuters, but also reduces energy consumption and emissions.
The transformation of urban landscapes. The widespread adoption of autonomous EVs will not only change the way we travel, but also reshape our cities and urban landscapes. As Seba points out, the shift towards transportation as a service will have profound implications for urban planning and real estate.
With autonomous EVs, the need for personal car ownership will diminish. Instead of owning a car that sits idle for most of the day, people will be able to summon an autonomous EV on demand, whenever they need it. This shift will free up vast amounts of space currently dedicated to parking lots and garages, allowing cities to repurpose this land for more productive uses, such as parks, green spaces, and affordable housing.
Furthermore, the reduced need for parking will also change the way we design our buildings and infrastructure. Instead of dedicating valuable square footage to parking spaces, developers can focus on creating more livable, walkable, and community-oriented spaces. This transformation will not only make our cities more vibrant and engaging, but also more sustainable and resilient.
Part 3. The impact on real estate. The rise of autonomous EVs and transportation as a service will also have significant implications for the real estate industry. As the demand for personal car ownership decreases, so too will the need for on-site parking in residential and commercial properties. This shift will allow developers to rethink the way they allocate space and resources, creating opportunities for more efficient and affordable housing.
In urban areas where land is scarce and expensive, the ability to repurpose parking lots and garages will be particularly valuable. Imagine a future where a parking lot is transformed into a vibrant community garden, or where a multi-story garage is converted into a mixed-use development with affordable apartments, retail spaces, and public amenities.
Moreover, the reduced need for parking will also change the way we value and price real estate. Properties with abundant parking may become less desirable, while those with easy access to autonomous EV fleets and public transportation may command a premium. This shift will require real estate professionals to adapt their strategies and rethink traditional valuation models.
Expert insights, the future of autonomous mobility. To gain a deeper understanding of the future of autonomous mobility, let's turn to some expert insights. Dr. Daniel Sperling, a professor of civil engineering and environmental science and policy at the University of California, Davis, and the founding director of the Institute of Transportation Studies, shares his thoughts.
Autonomous vehicles have the potential to transform transportation in ways we haven't seen since the introduction of the automobile. They can make our roads safer, reduce congestion, and provide mobility to those who cannot drive. But to realize these benefits, we need to ensure that autonomous vehicles are developed and deployed in a responsible and equitable manner.
Similarly, Dr. Alan Kornhauser, a professor of operations research and financial engineering at Princeton University and the director of the transportation program, emphasizes the importance of public policy in shaping the future of autonomous mobility.
The transition to autonomous vehicles will not happen overnight, and it will require careful planning and coordination between the public and private sectors. Policymakers need to proactively address issues such as liability, insurance, data privacy, and workforce displacement. At the same time, they must create an environment that encourages innovation and investment in autonomous technology.
Technological deep dives, the sensors and algorithms powering autonomous vehicles. To truly appreciate the potential of autonomous vehicles, it's essential to understand the technology that powers them. At the heart of every autonomous vehicle lies a complex system of sensors and algorithms that enable the vehicle to perceive, understand, and navigate its environment.
One of the most critical sensors in an autonomous vehicle is the LiDAR, light detection and ranging. LiDAR uses laser light to create a highly detailed, three-dimensional map of the vehicle's surroundings, allowing it to detect objects, measure distances, and navigate with precision.
In addition to LiDAR, autonomous vehicles also rely on cameras and radar to gather data about their environment. Cameras provide visual information such as traffic signs, lane markings, and pedestrians, while radar uses radio waves to detect the speed and distance of nearby objects.
But sensors alone are not enough to make a vehicle autonomous. The real magic lies in the AI algorithms that process and interpret the vast amounts of data generated by these sensors. Deep learning, a subset of AI that mimics the way the human brain learns, plays a crucial role in enabling autonomous vehicles to make split-second decisions and navigate complex environments.
Part 4, Societal Impact Analysis, the ripple effects of autonomous EVs. The adoption of autonomous EVs will not only transform transportation, but also have far-reaching societal implications. One of the most significant impacts will be on employment, particularly in the transportation sector. As autonomous vehicles become more prevalent, there will be a reduced demand for human drivers, such as taxi, bus, and truck drivers.
While this shift may cause short-term disruptions and displacements, it also presents opportunities for new jobs and industries to emerge. The development, maintenance, and operation of autonomous EV fleets will require a skilled workforce, creating new employment possibilities in fields such as software engineering, data analysis, and fleet management.
Another area where autonomous EVs will have a profound impact is public health. By reducing traffic accidents and fatalities, autonomous vehicles can save countless lives and reduce the burden on healthcare systems. Moreover, the shift towards electric mobility will lead to cleaner air and reduced greenhouse gas emissions, contributing to improved public health outcomes.
However, the transition to autonomous EVs also raises important ethical and social questions. How do we ensure that the benefits of this technology are distributed equitably? How do we protect personal privacy and data security in a world where vehicles are constantly collecting and transmitting data? These are complex challenges that will require ongoing dialogue, research, and collaboration between policymakers, industry leaders, and civil society.
As we explore the future of autonomous EVs,
how would your daily life change if you no longer had to drive yourself to work or run errands? What would you do with the extra time and mental energy?
Or imagine a city where all vehicles are autonomous and electric. How might the layout and design of that city differ from what we see today? What new possibilities and challenges might arise? Future trends and predictions, the road ahead. As we look to the future, it's clear that the convergence of AI, EVs, and autonomous technology will continue to shape the transportation landscape. While the exact timeline and trajectory of this revolution are difficult to predict, there are several key trends and developments to watch for.
One of the most exciting possibilities on the horizon is the integration of autonomous EVs into smart city infrastructure. By leveraging the Internet of Things, IoT, 5G networks, and AI-powered traffic management systems, cities can create seamless, efficient, and sustainable transportation networks that respond to real-time demands and conditions.
Another area to watch is the development of vehicle-to-everything, V2X communication. V2X allows autonomous EVs to communicate not only with each other, but also with infrastructure, pedestrians, and other road users. This technology can help prevent accidents, optimize traffic flow, and enhance the overall safety and efficiency of transportation systems.
Furthermore, as battery technology continues to improve and charging infrastructure expands, we can expect to see even longer ranges and faster charging times for EVs. This will not only make EVs more convenient for personal use, but also enable the widespread adoption of electric trucks, buses, and other commercial vehicles.
Part 5, Case Studies, Autonomous Vehicle Projects and Trials. To better understand the current state and future potential of autonomous vehicles, let's take a closer look at some notable case studies and projects from around the world.
1. Waymo. Google's self-driving car project, Waymo, has been at the forefront of autonomous vehicle development for over a decade. With millions of miles driven in various cities across the United States, Waymo has made significant strides in refining its technology and demonstrating the feasibility of autonomous ride-sharing services. In 2020, the company launched its fully driverless taxi service Waymo One in Phoenix, Arizona, marking a major milestone in the commercialization of autonomous vehicles.
2. Baidu Apollo. Chinese tech giant Baidu has been actively pursuing autonomous vehicle technology through its Apollo platform. The open-source platform, which has attracted over 100 global partners, aims to accelerate the development and adoption of autonomous driving technology. Baidu has been testing its autonomous vehicles in various cities across China, with plans to expand its RoboTaxi services to more locations in the coming years.
3. Helsinki Robot Bus Experiment. In 2017, the city of Helsinki, Finland, launched a pilot project to test the feasibility of autonomous buses in an urban environment. The project, known as the Shoa Baltic, involved a fleet of self-driving minibuses navigating a fixed route through the city center. The experiment provided valuable insights into the challenges and opportunities associated with integrating autonomous vehicles into existing public transportation systems.
4. Singapore Autonomous Vehicle Initiative, SAVI. Singapore has been actively promoting the development and deployment of autonomous vehicles as part of its Smart Nation initiative. The city-state has established dedicated test beds for autonomous vehicle trials, including the Center of Excellence for Testing and Research of Autonomous Vehicles, NTU, Citron, and the One North District. These test beds allow companies and researchers to test their autonomous vehicle technologies in a controlled environment, paving the way for future deployments on public roads.
These case studies highlight the global nature of the autonomous vehicle revolution and the diverse approaches being taken by companies, cities, and countries around the world. As these projects continue to evolve and expand, they will provide valuable lessons and best practices for the wider adoption of autonomous vehicles.
The role of policy and regulation. As autonomous EVs become more prevalent, policymakers and regulators will play a crucial role in shaping the future of transportation. Governments at all levels will need to adapt existing laws and regulations to accommodate the unique challenges and opportunities presented by autonomous vehicles.
One of the key areas of focus will be safety standards and certification processes. Regulators will need to establish clear guidelines and benchmarks for the testing and deployment of autonomous vehicles, ensuring that they meet rigorous safety requirements before being allowed on public roads.
Another important consideration will be liability and insurance frameworks. As autonomous vehicles blur the lines between driver and passenger, policymakers will need to determine who is responsible in the event of an accident. This may require the development of new insurance models that account for the unique risks and benefits of autonomous vehicles.
Privacy and data protection will also be critical issues as autonomous vehicles generate and transmit vast amounts of data. Policymakers will need to ensure that appropriate safeguards are in place to protect personal information and prevent misuse or unauthorized access to sensitive data.
At the same time, policymakers must also create an environment that encourages innovation and investment in autonomous vehicle technology. This may involve providing incentives for research and development, streamlining regulatory processes, and fostering collaboration between industry, academia, and government.
By proactively addressing these challenges and creating a supportive policy framework, governments can help accelerate the adoption of autonomous EVs and ensure that the benefits of this technology are realized in a safe, equitable, and sustainable manner.
Part 6. The Global Impact: Autonomous EVs in Developing Countries. While much of the discussion around autonomous EVs has focused on developed countries, it's important to recognize the potential impact of this technology on developing nations. For many countries in the global south, the transition to autonomous EVs could represent a significant leap forward in terms of mobility, economic development, and environmental sustainability.
One of the key challenges facing developing countries is the lack of reliable and affordable transportation infrastructure. In many cities, public transportation systems are overcrowded, inefficient, and often unsafe. Autonomous EVs could provide a cost-effective and scalable solution to this problem, offering on-demand mobility services that are accessible to a wider range of people.
Moreover, the shift towards electric mobility could help reduce the reliance on imported fossil fuels, which can be a significant burden on the economies of developing countries. By embracing EVs, these nations can reduce their exposure to volatile oil prices and improve their energy security.
However, the adoption of autonomous EVs in developing countries also presents unique challenges. One of the main barriers is the lack of reliable electricity infrastructure, which could hinder the widespread deployment of EVs. Governments and private sector partners will need to invest in building out charging networks and improving grid stability to support the transition to electric mobility.
Another challenge is the potential impact on employment, particularly in the informal transportation sector. In many developing countries, a significant portion of the workforce relies on driving jobs, such as taxi drivers and motorcycle taxis. The adoption of autonomous EVs could displace these workers, requiring targeted policies and programs to support their transition to new forms of employment.
Despite these challenges, the potential benefits of autonomous EVs for developing countries are significant. By improving access to affordable and sustainable transportation, these technologies could help reduce poverty, enhance social mobility, and stimulate economic growth. They could also contribute to the achievement of key sustainable development goals, such as reducing greenhouse gas emissions, improving air quality, and promoting sustainable cities and communities.
To realize these benefits, developing countries will need to take a proactive and inclusive approach to the adoption of autonomous EVs. This will require close collaboration between governments, industry partners, and civil society organizations to develop policies and programs that are tailored to the unique needs and challenges of each country.
It will also be important to ensure that the benefits of autonomous EVs are distributed equitably, reaching marginalized and underserved communities. This may involve targeted investments in infrastructure and services, as well as measures to promote digital inclusion and build local capacity for innovation and entrepreneurship.
By embracing the potential of autonomous EVs and taking a thoughtful and inclusive approach to their adoption, developing countries can position themselves at the forefront of the global transportation revolution, creating a more sustainable and prosperous future for all.
Part 7. The Ethics of Autonomous Vehicles. As autonomous vehicles become more prevalent on our roads, they raise a host of ethical questions that society will need to grapple with. One of the most fraught issues is the question of how autonomous vehicles should be programmed to make decisions in situations where an accident is unavoidable.
For example, if an autonomous vehicle is faced with a choice between hitting a pedestrian or swerving and risking the lives of its passengers, how should it be programmed to act? Should it prioritize the safety of its passengers or attempt to minimize overall harm? These are complex ethical dilemmas that have no easy answers.
Some experts argue that autonomous vehicles should be programmed to always prioritize the safety of their passengers, as this is the implicit contract between the vehicle and those who have entrusted their lives to it. Others contend that autonomous vehicles should be designed to make decisions that minimize overall harm, even if that means sacrificing the lives of passengers in certain situations.
Ultimately, society will need to have an open and inclusive dialogue about these issues to reach a consensus on the ethical principles that should guide the programming of autonomous vehicles. This will require input from a wide range of stakeholders, including ethicists, policymakers, industry leaders, and the general public.
The importance of public acceptance. Another critical factor in the widespread adoption of autonomous EVs is public acceptance. While many people are excited about the potential benefits of this technology, others are skeptical or even fearful of the idea of self-driving cars.
To build public trust and confidence in autonomous vehicles, companies and policymakers will need to prioritize transparency, safety, and accountability. This means being open and honest about the capabilities and limitations of the technology, investing in rigorous testing and certification processes, and establishing clear frameworks for liability and responsibility.
it will also be important to engage the public in the development and deployment of autonomous vehicles. This can involve public education campaigns, community outreach efforts, and opportunities for citizens to provide input and feedback on the technology.
By involving the public in the process and addressing their concerns and aspirations, we can create a shared vision for the future of autonomous mobility that reflects the values and priorities of society as a whole.
The role of collaboration and partnership. The development and deployment of autonomous EVs will require an unprecedented level of collaboration and partnership between a wide range of stakeholders. No single company or organization has the resources or expertise to tackle this challenge alone.
Governments, industry leaders, academic institutions, and civil society organizations will need to work together to create an ecosystem that supports innovation, investment, and responsible deployment of autonomous vehicle technology. This can involve joint research and development efforts, public-private partnerships, and cross-sector collaborations.
For example, governments can provide funding and support for research and development, while also working with industry partners to establish safety and performance standards for autonomous vehicles. Academic institutions can contribute their expertise in areas such as AI, robotics, and transportation engineering, while also training the next generation of professionals who will drive this industry forward.
Civil society organizations, including consumer advocacy groups and environmental organizations, can play a critical role in ensuring that the development and deployment of autonomous EVs aligns with the public interest and advances social and environmental goals.
By fostering a spirit of collaboration and partnership, we can accelerate the pace of innovation, address the complex challenges associated with autonomous mobility, and create a transportation system that works for everyone.
The AI-powered electric revolution is not just about transforming transportation, it's about transforming our world. As autonomous EVs take to the roads, they will reshape our cities, our economies, and our daily lives in ways we can only begin to imagine.
But this transformation is not without its challenges. As we've seen, the transition to autonomous EVs raises important questions about employment, equity, privacy, ethics, and public acceptance. To ensure that this technology benefits everyone, we will need to engage in ongoing dialogue, research, and collaboration.
At the same time, we must also recognize the incredible potential of autonomous EVs to create a safer, cleaner, and more sustainable future. By reducing accidents, emissions, and congestion, autonomous EVs can help us address some of the most pressing challenges of our time.
As Elon Musk and Seba have shown us, the future is not something that happens to us, it's something we create. By embracing innovation, taking bold action, and working together, we can harness the power of AI and EVs to build a better world for ourselves and for generations to come.
So let us charge forward with optimism, curiosity, and determination. The road ahead may be long and winding, but the destination is worth it. With autonomous EVs as our guide, we can navigate the challenges and opportunities of the 21st century and create a future that is brighter, cleaner, and more connected than ever before. We have the opportunity to create a transportation system that is not only more efficient and convenient, but also more equitable and sustainable. We have the chance to build cities that are more livable, communities that are more connected, and a planet that is healthier and more resilient.
So let us seize this moment and rise to the challenge. Let us be the architects of our own destiny and the creators of a better future. The road ahead is ours to shape, and with the power of AI and EVs at our fingertips, there's no limit to what we can achieve.
As we embark on this journey, let us remember the words of the great visionary Buckminster Fuller. You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete. With autonomous EVs, we have the opportunity to build that new model and make the transportation system of the past obsolete.
So let us embrace the possibilities of this AI-driven future, and let us work together to build a world where autonomous, electric vehicles powered by cutting-edge artificial intelligence are not just a vision, but a reality. The future is autonomous, the future is electric, and the future is AI-powered. Let's make it ours to create.
Do us a favor and please hit subscribe, and maybe even tell a friend. Now let's keep the discussion going, taking a look at